read it and is going to read it, and that's going to.
So it sounds very much like concurrent programming.
Yes, there's definitely a concurrency aspect to it that makes it different than, say, straight subroutines, and that's because I've got this shared data, this shared information model, okay, which provides kind of a backbone for what's happening. Sometimes we say that this shared information model is kind of like a whiteboard, and that these different stages are all kind of hovering around the whiteboard, and sometimes they're reading or writing into the whiteboard, possibly concurrently, possibly, yeah, in parallel. Yeah.
I'm not quite clear on the difference between the macro steps and the micro steps. And is it the case that the events that trigger macro steps are external events, and the ones that trigger micro steps are internal events, or?
Yeah, yeah. So at the macro level, what I'm focused on is just consuming one external event. Now, pretty much, when I get down into the micro level, this takes us into a detail. But one of the key things is, it may be that a milestone went through a stage closed. In kind of a slightly more practical sense, that means that the write lock that I had on some attributes down there is released. That means other guards and state and milestones can look at those attributes, by the way, whose value might have changed. And so now that's why some condition might go true. There is a technical thing where we talk about the event of a milestone going true. So there's an added little thing, but I would talk about that offline later. So let me,
I
in honor of the
can
clock. Yeah, so in honor of the clock, why don't we take a little break now? Anybody who wants to leave, needs to leave, feel free. Okay, you guys are too kind. So, Fiona.
I don't want to dwell on this too long, but I was a little bit unclear about how the detail of your environment snapshot. I know is it just status milestones, or is it other things, and is it always complete? Do you always know the status of the environment, and how complex is the representation?
For right now, and maybe I should mention this, all this stuff is hot off the presses. That hasn't even been written down completely. But anyway, for right now, for the kinds of results that we're working, all we need to know is what tasks are open. And I don't even think we need what was the read set when we opened it. But we're just keeping it for now. That's all we're keeping. So it's a very incomplete knowledge of the environment. Right. I mean, we could go there could be some next results where we get into more knowledge.
Something like it's 10 o'clock in the morning in Tokyo. You want to initiate some task that. Yeah.
Okay. Yeah. Right now we're not looking at the clock in particular, even though my example had that the reporting would be at the top of every hour. Okay. Yeah. Okay. Other questions?
Yeah, this is, this restriction that I view one marker step on its own for the correctness, right? Doesn't it mean that I restrict my possibilities to parallelize my tasks? Right, because
So my tasks are indeed possibly parallel. I should actually probably, next time I make the slide, maybe this is the one that just got launched, but maybe there's 3 others that have already been chugging away. And it could well be that for whatever reason both of these open in response to the same external event. It could be, and so it could be that in some case both of these tasks would be launched all in one macro step. Now, as far as the fact that I happen to be writing my micro steps kind of in a serial line, is that maybe part of what your question is? Why don't I kind of say, why can't I do this transition and this transition kind of in parallel? Is that maybe part of your question?
Yeah, if I order the micro steps on some topology of my model, right? Mm-hmm. And only process one external event at a time, right? means I don't know how I can parallelize this, right? I just know if I do it like this in a strictly, let's say, linear fashion, then it will be correct, right? Because if I parallelize something, some other event might happen in between, right? And is there some concept how to know how to parallelize after I've proven that if I go linearly it's correct? Is there some way to know which I can parallelize without compromising this correctness?
Maybe to rephrase your question, or at least rephrase it to something I can answer or think I can answer. I mean, certainly there's a question, if I have a bigger GSM schema with 100 stages, and maybe sometimes when I throw in an external event, there might be a ripple involving, oh, and by the way, maybe I've got many line items, maybe we have 30 line items, and I've got 20 procurement orders. So I might throw in one event, and then the ripple might actually be 10 long or 20 long. And for all I know, even the data was distributed, some things are distributed. Then there would be a question, wait, how can I, say, implement this efficiently? How could I introduce some parallelism in my implementation level to achieve what Rick is saying should be the official formal semantics? Okay, that's an open research question. And actually, Arno Jacobsen is kind of interested to work on it. And so there may be some work, on that coming. Something we haven't addressed yet. So what we're doing right now is we're trying to lay out a precise semantics. In fact, we're giving two equivalent characterizations. We're giving an operational characterization, and then with that little theorem, we've got, in essence, a declarative specification of it. So I've got two ways to specify it, and in fact, they're equivalent, provably equivalent ways of specifying. Okay, so now we feel like, it kind of matches the intuitions we understand from our business colleagues. It kind of fits our intuition of just applying the ECA rules, and it has this kind of alternative characterization that's maybe more amenable to doing some verification work. So now we feel reasonably confident about this, and so now it's time maybe to bring in some work on physical optimization. Yeah.
To follow up on that, what if there are different orders that this microstep can happen? So is there any guarantee to get the same formula, or will it be different?
It turns. One reason we don't necessarily like the acyclicity condition right now is that what's true is any order you go, you're guaranteed to get the exact same result over there. And we have some examples. I'll tell you what, let me take it up after the talk is over, but we do have some examples where it's a little annoying. We would prefer that there could be some non-determinism available. Another thing to keep in mind is this acyclicity condition we have, which is a little bit severe. Okay. Well, it's the first step. It's an acyclicity condition. It's a well-formedness condition that works out, that allows us to have these two equivalent characterizations. Okay, and we feel that that's very powerful as far as establishing a solid foundation so that we can do optimization below. We can talk about views of GSM above. We can do verification. Over time, maybe somebody here will come up with a richer, a more relaxed, well-formedness condition, but still preserve the structure of this kind of result. And that'll be a good thing. That'll be happiness, because we'll actually make the whole framework just a little more flexible, a little more, less brittle. So part, this is just a statement about trying to make headway, month by month on this overall research program. We're making headway with an acyclicity condition. We're not thrilled with it. We're reasonably happy with it. Okay, but then over time we may be able to generalize it.
Do you know what the complexity of verification is?
Ha! Thank you so much. I'll tell you in 5 minutes.
Okay.
So, what I'd like to do now is I'd like to talk about some basic verification results. And I'll start by mentioning some previously established verification results that were done for the business entities with a somewhat declarative but different lifecycle model, more limited lifecycle model. And then I'll talk about how we can take our GSM schemas and kind of reduce them down to the previous results. Okay? The short answer is P-space under various restrictions. Okay. Incidentally, I should say that, this work, we have data as a first-class citizen in our model, and so our state space technically is infinite because we could have, say, a dense linear order as our base domain. Okay. So all this verification work is very kind of new style, coming in part from UC San Diego, Victor Viano and Alain Deutsch, and then they got interested in business entities, and so then we've been working together on these kinds of results. So what's happening? Here's a typical verification question we might be asking ourselves. Maybe what happens is somebody starts out, just one of the questions, somebody has a business level scenario. Here's a scenario of what might happen. Somebody else came with a GSM schema, and now the question is, does that schema support this scenario? Are these compatible in a sense? Okay, any run through this scenario, could I actually run it through the completely specified GSM schema? Okay, we want to put that into a verification algorithm. So what we're going to do is we're going to take the business level scenario, we're going to try to write it down as a logical property. Okay, the GSM, we're actually going to, we want to take some, maybe should be something here, we want to take some formula characterizing the GSM, we want to stick it into our algorithm, and then we want to, get the answer. Okay, so that's the game that we want to play. Now, we are going to use some previously established results. Okay. What are some of our underlying assumptions? Okay, so this is just one class of verification results. We're actually opening huge verification questions here. This is just the beginning. Happily, Giuseppe and others are also starting to get interested by this area. So what we're going to assume for this is that there's a bounded set of instances that we're using, like we might say, only up to 10 line orders, line items, only up to 5 procurement orders. The use of the data in the collection types will be quite restricted, and I can't go into the details of that, but anyway, you can look at the second paper. So now, what are the features shared between the previous work and this work? Well, we are using a very data plus process perspective in both cases. We're using the business entity paradigm. We've got a declarative specification of the life cycles, even in the previous work. And actually, in the previous work, you can have a fixed external database, and so we can have that for free. Now, what's the key difference? The key difference is that in this work, all of it, it was assumed that the tasks were applied sequentially. So under some conditions, a task became eligible. You went out to the real world, you asked for a result, you wait around. Only after you get the result back, then you ask, okay, is some other task eligible? So all this work is sequential. The big difference with GSM is that we're allowing for the parallelism. We're allowing that I open one stage, launch a task, open another stage, launch.